So this weekend, I managed to sleep in until 2 minutes before the contest started. It was glorious and much needed, but it means I don't have a direct recording. So I'm going to record my solutions as I've done before. It's unfortunate. It was, I think, the fastest time I've ever finished a contest. Anyway, Biweekly contest 112, virtual contest, let's go. Let's see how much my time improves when I already have all of the solutions. Okay. As always, open them all now. Okay. First question. I have two strings, both of length 4. This is important. Of lowercase English letters. I can perform a swap between indices that are 2 apart. So I could swap 0 and 2, or I could swap 1 and 3. And I want to see if I can make them equal. So examples, here in this one, I swap indices 0 and 2, the A and the C, and I swap indices to 1 and 3, the B and the D. Easy peasy. Here, I have all the right letters, but I can't make it with swaps, right? A right now is in position 0. I can only swap it with position 2, but I need it to be in position 1. So this being a question where I know the strings are exactly a length of 4, my thinking was the easiest way to do this question is to just look at all of the possibilities. It doesn't really generalize well, but for a length of exactly 4, it works fine. So either position 0 and position 2 match right now, or they're the reverse of each other, right? If this were A and this were A, and this were C and this were C, that would be fine. It also works that this is AC and this is CA. So they have to be either the same or swapped. Ditto for positions 1 and 3. This is BD. If this were BD, that would be fine. It's also fine that it's DB. But it wouldn't be fine if it were BB or DD. They have to both match or both just be the swap. So I just look at all the possibilities. Either they both match, the zeros are the same, and the position 2s are the same, or they both become the same when I swap them. 0 and 1 is 2 in the other, 2 and 1 is 0 in the other. Okay? That covers positions 0 and 2. Exact same thing for 1 and 3. Either the 1s and the 3s match, or the 1s and the 3s are swapped. So I need to meet both conditions. So false if this one isn't, if these aren't true. False if neither of these are true. But once I've gone through that, then true. Let's see if it still works. Wow, magic. True. That's not using example test cases. Whatever, I know this works. Wow, shocker. I didn't change the solution, and it still worked from when it worked last time. Okay, so in a contest, normally I think this is totally fine, that I'm really hard coding, not quite hard coding, going through all the possibilities based on constraints and not having the solution generalize well. In this particular case, though, it comes to bite me a little bit because, same question, but more general. Okay, how's it different? So now the lengths don't have to be exactly 4. And now I can swap anything where the difference is even. Note this would work the same if the difference had to be 2, because I could just like swap, and go along to the ends. So even if I generalized it where I could only swap at 2, that would be the same. But basically, right now the difference is even, and I can swap those. So again, return true if I can make them equal, false otherwise. So I want to look at first the even indices, even because it starts at 0, even though it's the first one, even. So here that's A, C, B. Here that's C, B, A. Same letters, different order, but that's fine. Now if we check the odd, we have B, D, A, and here we have A, D, B. Again, same letters, different order is fine. So here's the specific swaps we have to make. I personally don't really care about the specific swaps. I just care whether it's possible. Here, again, we have all the right letters, but they're not distributed well. Here, our even letters are A, E, and here it's B, A. Not the same. Obviously, B isn't the same as E either. So, what I'm going to do here is basically this is an anagram problem. If you've done the problem where you're checking two strings of the same length are anagrams, I'm really just doing that process. But I need to do it twice. I need to do it for the odd indices and for the even indices. So that's what I do. So first, I'm dividing string 1 into even and odd characters. Even characters are going to be where mod 2 is 0, so that's at indices 2, 0, 2, 4, 6, 8, 10, etc. Odd is everything else. Okay. Do the exact same division for string 2. Again, here are indices 0, 2, 4, 6, 8, 10. Here are indices 1, 3, 5, 7, 9, 11. Okay. So basically, once I have these, the evens have to be anagrams of each other, and the characters at odd indices have to be anagrams of each other. So the fastest way in terms of writing code is to just sort them both. This is n log n. It's possible to do an O of n. If this were a harder problem with looser constraints, that's what I would do. N log n is obviously fine with 10 to the 5th. So yeah, I just sort the even ones, make sure they match, sort the characters at odd indices, make sure they match, and that's how it works. So this didn't take a lot longer to write than the first one, but in this specific case, if I had done the first one in a more general way, then I potentially would have had this solved right away. So I guess even in a contest, there can be a disadvantage to not generalizing. But it took like a minute, so a minute or two, whatever. Okay, this is where it gets more difficult, a little bit. So maximum sum of almost unique subarray. I have an array, M and K. I want to find the maximum sum of an almost unique subarray. So subarray is length K. It has to be almost unique. And almost unique means there are at least M distinct elements. Okay, I have a beef with LeetCode here. When I did this the first time, in the actual contest, it said there were M pairwise distinct elements. And I was confused by what that meant. I assumed it meant M pairs of elements that were distinct. What it really means is that you have M elements and any pair of them is distinct. Another way of saying that is there are M distinct elements. But I was confused by it. I submitted 2 wrong answers, got my 10-minute time penalty, hurt my rank. I don't know if I suspect that was not intentional, given that they've since changed it, but if it was intentional and designed to trick me, then well done, LeetCode, you successfully tricked me. Anyway, we're going to ignore the complicated thing I tried to do with like looking at all the different pairs and seeing, okay, here's a hash of the count of all the unique elements, let's do each pair and multiply the count of each, because I'm not even sure that would have passed time complexity. And ultimately, don't have to do it. I just want M unique elements, contiguous subarray. Okay, so this is a contiguous subarray of length K. I want to look at each of the continuous subarrays of length K. That tells me it's going to be a sliding window problem. So I first look at these 4, then I move 1 over, then I move 1 over. And each time I want to be keeping track of the total sum of the array, so I don't have to sum each time for the comparison, and also the number of distinct elements. Here, number of distinct elements is 4, 4 again, now 3. Here they're making M be 1 less than K, but it could just be 1, so that's fine. Here M is the same as K, and there are none, because there are only 2 distinct elements total. there would be none pairwise too, which is why my misinterpretation wasn't clarified, because if it were longer, I could get more pairs. When it's only 3, I can only get 2 pairs, which is less than 3. Okay. So, sliding window. Basically, what I want to do is I'm going to start with the first k elements, and I want a count hash. I want to know not just a set of the elements, but the actual count of them. And the reason is, this way, when I'm moving my sliding window, I can increment and decrement. So I know, like, oh, I just lost a 3. Now I know if there are still any other 3s, which I wouldn't in a set. So I create a count of the first k, find the sum of the first k, and I'm going to check this one right away. Is this almost unique? That's just the length of the count, because it's the length of the number of distinct elements. If so, I start my max at the current sum. Otherwise, I start it at 0, because I'm going to return 0 if I can't find a valid almost unique array. Okay, now I just need to iterate through the rest of the array. So, again, I'm starting at k. Each time I go to a new element, I'm going to decrement that element in count. I'm going to remove it if it was the last one, because I don't want to have phantom, like, this element used to exist, but now there is 0, because that will upset my number of unique elements. And, of course, I decrease the sum as well. Okay, so basically I had these 4 elements. As I'm moving, I'm going to remove the first one, so now it's only 3. And, of course, next I'm going to add the next one. So here I decremented count, here I increment count. Because I did this with a hash initialized at 0 instead of using the built-in tally method, it's fine if this element doesn't exist in count yet. It just starts it off as 0 and then it will increment 1. No error. And I increase the sum as well. Makes sense. I'm going to go now, since I have a new potential almost unique array, and it has potentially a higher sum, I check, is it almost unique? If so, is the sum bigger than max? If both of those are true, then that's the new max. So I do this for all the rest of the array, going from k to the end, and then I just return max. Make sense? And it's a reasonably straightforward sliding window. Really, the key is to make sure you're doing some sort of tally, like a count, instead of just doing a set to keep track of the number of elements or checking the number of elements each time. Either of those would hurt you for time complexity. But if you're doing a count, then all of these are O of 1. O of 1 to decrement 1, O of 1 to delete in a hash, O of 1 to decrease sum, O of 1 to increment, O of 1 to increase sum, and O of 1 to check. So this is just O of n overall. O of n for space as well, because I have the hash. And that's it. Okay. And now the last question, the hard question, the one that determines how long this contest takes overall and whether it's one of my fastest. So it looks a little complicated. It makes more sense that it's a little easier than it seems, but let's go through part by part. So we have a string and we have k. A k subsequence means that it's substring of length k, subsequence of length k, because it doesn't have to be consecutive. It's just taking k elements. All the characters in this subsequence are unique. Okay? So we find the count of each character, and then the beauty is basically the sum of the overall counts. So that seems a little odd, but basically in this case, B appears 3 times in the entire string. That means that B is going to have a score of 3. So if my substring has a B, I get 3, not points, I get 3 for it. Here, I'm doing a subsequence. I keep saying substring. Anytime I say substring, I mean subsequence. Sorry. Yeah. My subsequence has length 2. So I have 3 distinct letters, A, B, and D, right? I know that every character in my k subsequence has to be unique. So I'm really just going to choose 2 of these. I could do AB, AD, or BD. So here's the AB option that has a score of 4 because there's 1 A and 3 Bs overall. The AD option has a score of 3 because there's 1 A and 2 Ds. The BD option has a score of 5 because there are 3 Bs and 2 Ds. So return an integer denoting the number of k subsequences whose beauty is the maximum among all k subsequences. And we're going to do the mod thing because it's big. Got to watch out for this. I have gotten a time penalty for not including this before. This time I did. My time penalties were for misunderstanding the other question. Okay, so we need to find what is the maximum score we can get. Now that's pretty straightforward if we actually do the count of everything. Like obviously, we want to choose the ones with the 2 biggest scores. So biggest single score for one letter is B at 3, then D at 2. If it were 3, then we'd include A also. So obviously, we're going to want to find the score of each thing. We're going to want to do some tally thing. Let's just do one more example, though, because this one's really interesting with the tie. So here I'm picking 2 of them. I know I'm going to want to pick the C because C has a score of 2, B and A are only 1. But where this gets complicated, and what makes this a hard question, is there could be a tie. I could pick the A or the B, so I can't just sort it and pick one of those. I have to consider the possibility where I do C and A, and also the possibility where I do C and B. Okay. This one's pretty straightforward. I have to pick literally every letter. Notably, in this one, there are 2 ways to do it. Even though I'm picking every distinct letter, since there are 2 Bs, there are 2 ways in total. Okay, let's get down to strategy. And this has to be less than n squared, so we're aiming probably for O of n, maybe n log n. So obviously we're going to tally. I want to get the scores of each character. Now the interesting thing is, once I've done that, it doesn't actually matter what the specific characters are, right? So like here I'm doing my count. I know that this is 1, this is 2, this is 1. I could think of it as A1, B1, C2, but really it's just 1, 1, and 2. So here's a string and like if there are no k subsequences, just return 0. Don't do the rest of this. Okay, annoying edge case. So here I wrote the string that has a little more repetition. You can see that the C occurs 3 times, D is once, B, A, and E are all twice. So when I get my vowels, it's just going to be 1, 2, 2, 2, 3. Okay? So I want to figure out what the minimum value I include is. That's pretty easy. It's just vowels at negative k. So here it's 3. That's going to be right here. Oh, wow. I need to include a 2, something that occurs twice, something with a score of 2. Now, the higher vowels, anything above that, I have to include, right? I include the highest, so anything with a score more than 2, I'm definitely going to include. So here, that's just 3. I start my project at 1, and I multiply it by all of these. So, oof. I know that there are 3 different ways I can choose this, right? If there are 3 C's, I could have my subsequence include this first C, this second C, or this third C. 3 ways to do it. So I just start by multiplying all of those together. Right now it's just one number. Product is 3. Okay. Now, I know I'm going to pick some number of these 2's. So first, I'm going to determine how many 2's there are in total. Then I'm going to determine how many I'm actually going to select. So here, there are 3 values that have a score, 3 letters that have a score of 2. And I'm going to pick 2 of them. That's because I'm picking 3 in total, and one of them is more than 2. So Now I know that I'm going to pick 2 of these 2s. I don't know which, but I know that they all have a score of 2. So regardless of which ones, there are going to be 2 options for each one I pick. Again, I can just do product times the min val, however many times I'm selecting. So it's times 2 for the first one, times 2 for the second one. Okay. Now the last part here is it's actually not just picking 2 2s. It matters which ones. I could pick B and A. I could pick B and E. I could pick A and E. So what I want to do is figure out how many ways I can select 2 numbers from this group of 3 to include in my subsequence. Okay? So there's a math formula for that. In combinatorics, just choose. Probably there's a built-in function for it, but I didn't really want to look it up, and it's pretty quick to write. Basically, I multiply I multiply these things, I divide by these things. I can go a little in details if I want. If I had, say, 7 choose 3, the way it works is there are 7 options for the first thing, 6 for the second, 5 for the third. But order doesn't matter. I could pick ABC or BCA or CBA. So like this would just be if the order did matter, I pick 7 for the first, then 6 for the second, then 5 for the third. But it doesn't matter what order I actually pick those 3 in. So I'm going to divide by 3 for the first one of the ones I'm picking times 2 times 1. Again, if you want more detail on this, just look up combinatorics or math choose operation. Probably built in. I wrote it explicitly here. But here I'm choosing which of the min val elements I'm going to choose, which of the letters with a score of 2 I'm going to choose. Turns out there are 3 ways to do that: BA, BE, or AE. And I get then my final answer. I need to make sure to do mod, not for these test cases, but for later ones. And then once I do, it works. So again, this one was longer and more complicated than most. Running through it quickly, find the score of each character, get an array just of those scores sorted, find the minimum score I'm going to take. Any score above that, I definitely take. So I'm going to take all of those, put them in my product. Now, of the min score, in case there are ties, figure out how many of those I'm going to take and multiply the product by those scores. And then finally, since there are ties and I might not be picking all of the ones with that min val, I figure out how many different ways there are to select however many I'm selecting with that val, multiply that, and then finally modulo for my final answer. And that's it. So let's see how I would have done in the contest if I did it that quickly with no time penalty. Wow, number 17. Obviously, I was a little slower doing things the first time. I wasn't explaining as much, so it's actually not a ton slower. I think my time was like 28 minutes, except I got the 2 5-minute penalties, so my actual time was 38. Anyway, as always, hope this was fun, interesting, and helpful. And that's it. See you next week for next contest.